Hello everyone. So in this opportunity, I will explain about relation. But first of all, let me introduce myself. My name is Lidya. You guys can call me Lidya, and I'm from class 4C with the last 3 digit student ID number is 044. Okay, so what will we learn in relation? The first one, we will learn about the definition of relation. The second one is how to express relation. And the third one is types of relation. Okay, so we move to the first one is the definition of relation. So basically, the relation in math is a relationship between members of a set with the members of the other set. The relation from set A to set B is connect the member of set A to the member of set B. Okay, let A and B be two sets. The binary relation R from set A to B is a subset of A cross B. Or the notation is like this. R is the subset of A cross B. And then we call that A cross B as nothing but A comma B. Then A is element of set A and B is element of set B. We use the notation ARB to denote that A comma B is a element of R, or the A comma B is belong to R. And then we use the notation A to denote that A comma B is not belong to R. And then relation can be divided into two. There are relations which are function and relations which are not function. Relation which are function from set A to set B is a relation which maps every member of set A to exactly one member of set B. This kind of relation can divide into three types. They are injective function, surjective function, and bijective function. And then relation which are not function is relation which maps every member of set A to not exactly one member of set B. It means every member of set A can have more than one pair in set B. And then we will talk about relations that are function. So this is the picture of that three kind of relation that are function. The first one is injective function, and then second one is surjective function, and then the third one is bijective function. We'll talk about the first one, injective function. So injective function is a relation which maps every member of set A to exactly one member of set B. But in this relation, every member of set B cannot have more than one pair in set A. Now, if I add a member in set A, let's call it D, and then I draw an arrow from D to 3, and this is called not injective because there are a member of set B which have more than one pair in set A. Okay, we move to the second one, surjective function. So surjective function is a relation which maps every member of set A to exactly one member of set B, but in this relation, every member of set B must have pair. It's no matter the member of set B have one or two or three pair in set A. Okay, if I add a member in set B, so this is called not surjective because there are member of set B which don't have a pair in set A. And then we move to the third one, the bijective function. So bijective function is a combination of injective relation, injective function, and surjective function. It means this relation is maps every member of set A to exactly one member of set B, but in this case, every member of set B might not have more than one pair in set A, and all the members of set B must have a pair in set A. Just like in this picture. Okay, next we will talk about how to express relation. So to express relation, there are three ways, namely arrow diagram, Cartesian diagram, and set of pairs. Okay, let me make an example that R is a relation square number. So to express this relation, we can use the three ways. The first, we will talk about arrow diagram. Now, we have a set A, with members 1, 2, 3, and 4. And then set B with the members of set B as 1, 4, 9, 16, and 25. Now, and then we draw an arrow from 1 to 1 because 1 is a square number of 1, and then an arrow from 2 to 4 because 4 is a square number of 2, and then an arrow from 3 to 9 because 9 is a square number of 3, and then an arrow from 4 to 16 because 16 is a square number of 4. Okay, that's for the arrow diagram. And for the same example, we will try to make it in the Cartesian diagram. So the Cartesian diagram is a type of diagram consisting of a coordinate system of the x-axis and y-axis. So for the same example, we put the member of set A in the x-axis and the member of set B in the y-axis like this. And then we pair the member of set A and the set B, such as the 1 we pair with 1 because 1 is a square number of 1. And then we pair 4 with 2 because 4 is a square number of 2. And then make a dot here. And then we pair 9 with 3 because 9 is a square number of 3, and then we make a dot here. And then we pair 16 to 4 because 16 is square number of 4, and then we make a dot here. Then we draw a line. Then we draw a line through all the points. So this is called Cartesian diagram. And the last one, the relation between two sets can be expressed with a set of order pair x, y, which x is an element of x, y, which x is an element of set A, and then y is an element of set B. So we pair set A and set B, and we write like this. This is the x element and this is the y element. So the conclusion, the set of order pairs in the same example is like this: 1, 1, 2, 4, 3, 9, and 4, 16. And then we move to types of relation. The first one is a reflective relation. The second one is symmetric relation. And the third one is transitive relation. So I will explain about the first one. So I will explain about the first one, reflective relation. For all A comma A is belong to R. This must belong to R, or A comma A is element of R. Now, so we have, now we make an example. We have two set A and set B. With the member of set A is A, B, C, D, and the member of set B is A, B, C, D. So basically, this relation is arrow to self. So for all element X is X comma X. So it must be an arrow from A to A, B to B, C to C, and D to D. We can also draw a arrow from D to B, or B to C, or A to B. It's still called reflective. And then how the not reflective look like? Okay, so we take the same example, set A and set B, with the same member A, B, C, D, A, B, C, D, and draw a line, an arrow from A to A, B to B, and C to C. This is called not reflective. Now, because there is not an arrow from D to D, that's why this is called not reflective. Okay, and then we move to the symmetric relation. For all A and all B, A comma B must belong to R, implies that B comma A must belong to R. Okay, so we will take the same example like before. Set A and set B with the same member, A, B, C, D, and A, B, C. Okay, for this kind of relation, if we have an arrow from A to B, we must have an arrow from B to A. That's why this kind of relation called arrow back. Now another example, if we have an arrow from C to D, we must have an arrow from D to C. Now this is called symmetric. Okay, what if we have an arrow from C to B, but there is no arrow from B to C? Now this is called not symmetric. Okay, and the last one, we'll talk about transitive relation. For all A, for all B, and all C, and A comma B is must belong to R, and B comma C is must belong to R, implies that A comma C is must belong to R. This relation is also called shortcut. If we have a relation from A to B and then B to C, we must have a relation from A to C. That's why it's called shortcut. Take the same example. Number A, B, C, D. Number set B is A, B, C, D. Okay, if we have a relation If you have an arrow from set A to B, and then B to C, we must have an arrow from A to C. Or another example, if we have an arrow from C to A, and then A to D, so we must have an arrow from C to D. This is called transitive. Okay, so that's all from me. Thank you so much for the attention and goodbye. See you.